In this video we're going to look at Pythagoras' theorem. Before we go into any formulas, we're going to first of all look at where it comes from and where it's used. As a bit of background, it's important that you realise that a right angle might look like that angle there, and it's got 90 degrees is the magnitude or the size of it. So it's where one line is perpendicular to another. Another thing you'll need to recall for this video from your earlier work is the area of a square is side times side, or S times S. You'll need to recall that for this. So you can see that I've drawn a little right angle triangle here. The right angle is shown there, and we need to know where Pythagoras' theorem comes from. Pythagoras' theorem is c squared equals a squared plus b squared. A, B and C are the lengths of each line, so we would call one of the short sides A, we would call one of the other shorter sides B, and the longest side, which is also called the hypotenuse, that's called C. To find the length of C squared, we add A squared plus B squared. You might have even seen that before, but why does it work? Well, let's look at A squared. Here we have A, we've got A here, and so if we turn that into a square, we've got 1, 2, 3, 4, 5, 6 of these little units. We need to go across 1, 2, 3, 4, 5, 6 units there. Again, we counted the same number along, 1, 2, 3, 4, 5, 6. And we turn that into a square. So here we go, and we complete this square. And so we have an area, and remember, area of a square is side times side. All of the sides are A, so to get this area we would have A squared. I've now gone ahead and done the same with side B. You can see there we've got side B is that length. To turn that into a square, we need another length of B. In fact, all the sides need to be B. To get the area of this, it's side times side, which is B times B, and that area would be B squared. So that accounts for that. So those two together, A squared plus B squared, should be the same area as C squared. So C squared needs to come out here at the right angle, to make a proper square. How can we show this? The answer is with a pair of scissors. I'm going to do some cutting now. So now I've cut out the first square. I'm going to cut out the small square here, A squared. Alright, so there we can see we've got A squared and B squared. Now, do they fit? Well, they don't fit on C squared, so is Pythagoras' theorem wrong? Because this is hanging over the edge. That sort of sits in there, but it's got gaps. What's the story? Well, we may need to do some more cutting. Well, it's a bit of a rush job, but basically I've managed to put the square from A squared, the square from B squared, cut it up into little bits. It is a mess. If I were a bit more careful, it would cover the whole square of c squared. So c squared is the same as a squared and b squared put together. They've got the same areas, and that's Pythagoras' theorem. That's where it comes from.